Hey everybody, welcome back to another fun and exciting Algebra 1 video. Today's lesson, we're going to be jumping into chapter number 5. In chapter number 5, we're going to kind of put some of the things together that we've been working on as far as equations go, as far as graphing goes, and we're going to kind of plug some of those things in together, and we're going to work through some things called systems of equations. You can go ahead and open up your book there to page 154, page 154, chapter number 5, Systems of Equations, and you'll see the different lesson titles. And today's lesson 5.1, we're going to be talking specifically about systems of equations and graphing them, how to solve them by graphing. Okay, and so I guess the first thing that you probably are wondering is what in the world is a system of equations? So a system of equations right here, it consists of two or more linear equations. What's a linear equation? Well, it's the equation with the x and the y, the one that we can put on the graph and that we can draw a line with, okay? And so the equations we've been working with the last few chapters. And so the system, the only thing that's different about the system is now we're going to put two lines on the same graph. And so up until now, we've really only been graphing with one line on each graph, but now we're going to put two different lines on the graph. And so the system of equations, that's all it means, is it's two separate lines, or it could be more. It could be 3, 4, 5 lines on the same graph. But really, for the most part, we're going to deal with just two lines on the same graph. And so the solution to these is where those two lines cross each other. If you look down here on page 154, you're going to see these two lines cross each other right here at 3, 2. 3 on the x, 1, 2, 3, and then 2 up on the y, 1, 2. What does that mean? It means that's the point of intersection. That's the point where they cross each other. That's the point at which in this case, this yellow line crosses over the purple line. Okay, and so we can figure that out. There's different ways to solve these. One way is by graphing. We're actually going to learn 3 different ways to solve these. The first way that we're going to learn is by graphing them. All right, so here we go. How do we do that? Well, it's actually fairly simple. What you do is you take your line. So this is this yellow color right here. 2x plus 3y equals 12, and we just graph it. We just put it on the graph. And then we take this other line right here, this 3x minus y equals 7, and we put that on the graph. And then wherever they cross, that is our solution. Now, there's another thing that you can do here, and you can say, what if they give you 2 points? In this one, they gave you 2 different points. So that you might be saying, what is this 2, 1 here? Well, that 2, 1 is another point that they just randomly give you, and they say, is this a solution? So the way that you can do that is you would just take this 2, 1, and you would say, is this the point that crosses? And the answer would be no. Another way of doing that is to actually plug in these 2 points to both of these. And if they work, okay, and they have to work in both. For example, you could take a point on this purple line, any point, and you could plug it into the purple equation and it would work. But when you plugged it into the yellow equation, it would not work unless it's the solution, unless it's where they cross. Does that make sense? So in other words, you could pick a point down here, and you could say right here, okay, so this is 1, negative 4. So if you plug 1, negative 4 into this purple one, it would act like a solution. But then when you plug it into the yellow one, it would not act like a solution. It would give you something like this. 7 does not equal 12. 5 does not equal 7. If you get, you can look over here, if you get 12 equals 12 or 7 equals 7 or whatever it is, then you know that that's a solution. So both of them, it has to work in both of the equations in order for it to be a solution. Okay? The only solution to this system of equations, there's only one solution. And that solution is right here where those 2 lines cross each other. All right, turn the page over. Now, how are we going to solve these things by graphing? So what I said earlier was we're going to put them on the graph. We're just going to graph both lines. Remember, there's several different ways to graph. You can graph by y-intercept. You can graph by doing a chart and just kind of plotting points. You can do it a number of different ways. I think the easiest way, it just for me, is a lot of times just the y-intercept graphing. Just get where it crosses the y-intercept, and then count the slope off of it. But you can do it however you want to graph these lines. So then, step number 2, you're just going to locate where the lines cross each other. Once you've located that, that's the solution. Now you do want to check the solution to make sure that you didn't mess up when you graphed it. And so let's go ahead and try one of these, okay? So you can see it here, but I'm going to do it on the piece of paper as well. So if you'll take out your notebook, just go ahead and follow along with me while I do it here on my computer screen. All right, so here it is. So we have y equals negative 2x plus 3. That's the green line. And then the red line, the pink line, is y equals 1/2 x minus 2. So let's go ahead and let's solve. Let's start with the green one. So I'm just going to come over here and we'll work these off to the side. So y equals negative 2x plus 3. Now, let's just, we're going to graph it. So we don't have to really solve this out. It's already solved out. So what is our slope? M equals, there it is right there, negative 2 or negative 2 over 1. Okay. We always have to have that over 1 if it's a whole number. Don't forget to put this denominator, because if you don't, then you won't count over the one spot on the x-axis. Remember, this is our x, and excuse me, I wrote that wrong. This is our y, and this is our x. Okay. Then we have our b. What is our b? That's our y-intercept, and that is a positive 3. Okay. So this is important to us, and this is important to us. So we're ready to go ahead and we're ready to graph that green line right now. So let's go ahead and go over there. And what do we want to graph? We want to graph our y-intercept. So plus 3. So we're going to come over here. So we're going to go up 3. 1, 2, 3. And that is where it crosses. That's where our green line crosses the y-axis. Okay, so come back over here. Now we need this information right here. We need our slope, negative 2, 1. Negative 2 on the y, 1 on the x. So we're going to come back over here and we're going to go negative 2, 1, 2. And then we're going to go 1 on the x, 1 over positive. So our other point is going to be right here. So this is going to be our line, our green line. Okay. And now we need to come over here and we need to do our red line. Okay, in the book it's red. On my screen it's kind of more of a pink color. So, but that's the one that we need to do next. If you notice, this one is also solved. This one's already solved for us. So what is our m? Our m is our slope, and our slope is right here. It's positive 1/2. And then what is our b? Our b is our y-intercept, and this time it's negative 2. So we're going to come over here and we're going to put our dot on negative 2. So we're going to go down 2 spots. So there's our y-intercept, and then our slope is this 1/2. Positive 1, so we're going up 1, and then over 2. 1, 2. And crazy enough, I think we just, when we did that, I think we just, that's a terrible line. I think we just solved our equation. So in other words, where does our line meet? Where do the two lines cross each other? Well, it's at, remember, we have an x comma y. This is our coordinate plane that we're looking for. Let me change that color so it doesn't look like it's the pink line. So we have an xy, x comma y, okay? And that is at this point right here. So what is our x? 1, 2, it's 2 over. So our x is 2. And then we're going to go down 1 on the y. So if we go down, it's negative. So that's going to be a negative 1 over here on the y. Okay. If we go back over here to the book, we're going to check our solution. And we have basically the same graph that they do. Here's our green line, and here is our pink line, and the solution is 2 comma -1. Okay, how did we do that? All we did was solved it, or we just graphed it by slope intercept. Okay, and so we just figured out what the slope intercept was, and then we went through and we graphed it. Now, one thing that I am going to challenge you to do is I am going to challenge you to solve this or check this to make sure that this actually does work for both of these. All right, so let's check this real quick by plugging this back into these two equations. We're going to do both of those equations. So the first one was y, and instead of the y, we want to put -1. Why -1? Because that's it right there. Equals -2x, and x is 2, plus 3. Okay, so that's this right here. I just rewrote this down here. And then instead of the y, I put y from over here. And instead of the x, I put 2 from over here. Now, what we want is we want this to be -1 equals -1. That will mean that we solved it correctly, and that will mean that it checks on that line. So if we do our order of operation, -1 equals, if we have this multiplication problem, that's -2 times 2 is -4, plus 3, -1 equals -1. This one checks. So now we want to do the same thing with this second equation, the second line, this pink line. And so we'll do the same thing. I'll do it right over here. We'll do y equals, well, not y, but -1 equals 1/2 x, which is 2, minus 2. All right, so same thing here. We're going to multiply this together. You can put 2 over 1 if you want. It's going to cancel. We're going to get -1 equals 1 minus 2. Well, 1 minus 2, let me bring it up here. 1 minus 2 equals -1. And so that one checks again. So these both checked out. With this solution, these both ended up satisfying that that check. They both satisfy. In other words, that point that we marked is indeed the correct point. Okay, so go back over here to the book real quick. This point right here is indeed the solution to this. Why? Because when we checked it, we get -1 equals -1 on both of the lines, both of the equations. That works. If it didn't work on one of them, then that would mean that we have a point on the line, but we don't have the exact crossing point. When it solves both of them, we know that we have the exact crossing point. What happens if it doesn't solve either one of them? Well, that means that our point is not even on either one of the lines, and we've done something wrong, and we have to go back and fix it. All right, let's look at this next one real quick. So here's the B solution, and now this time they've graphed this. Now this one is not in y-intercept form, and so we're going to have to either put it in y-intercept form, or we're going to have to graph it by the intercepts. And that's what they've done in this case, is they've graphed it with the intercepts. So they've basically figured it out. They put a 0 in for both of them, and they graph this line. Graph however you want to. If you're having trouble graphing, go back and watch the video on graphing. Go back to chapter number 3 and watch those videos on graphing so that you can remember how to graph these. You have to be able to graph in order to solve these. So go back and watch the videos. On this, they put the green line on, and then they put the pink line on, and where it crosses is 4, 1. And so 4 on the x, 1 up on the y. Okay, they checked it, and they get 6 equals 6 and 3 equals 3. So here in the practice, they say determine which point is the solution. The way that you do these ones here is you're just going to plug those in, and you're going to say, does this equal, or you could graph them if you want to. You could take these two systems and you could actually graph them, and you could see, okay, which point does it cross? Or probably the easier way is to just go ahead and plug those in and say, okay, does this solve out? Is this correct? And then here, you're just going to take these, and they've already graphed it. And so you're just going to say, where is that crossing? And then as you're going through your work, these ones are where you're actually going to put that on a piece of graph paper. You're going to graph those lines, you're going to graph those equations, and wherever they meet, wherever they cross, that's going to be the solution for the problem. Okay, easy peasy, right? So if you've been paying attention, if you've been keeping up with the graphing and with the algebra part of this, this shouldn't. This is just another lesson that just kind of takes two things that we've already been doing and puts them together and says, okay, now where do these lines cross? So if you're struggling, it's probably not with this lesson you're struggling with. It's probably somewhere with the other ones. So again, I encourage you, go back and watch those other videos and make sure that you know how to graph these lines. Make sure you know how to get them in the proper form, whether you're graphing from y-intercept, whether you're graphing from standard form, whether you're graphing from intercepts, or however you're deciding to graph these. Make sure you know how to do it. Go back to that lesson, and then this lesson should be, once you're able to do that, should be a breeze because you're able to do those other skills, and then you're just doing it twice. Wherever it matches up, that's the spot right there. All right, that's all I've got for you. Hopefully you learned something in this lesson. Make sure to slide it back, watch it again if you missed anything. We'll see you later. Have a good one. Bye-bye.